Okay, so here we go. It says, this is the particular solution. So hands up, whole room. So what column are they talking about so far? Hands, come on. Like all I've done is circle that and said that's the particular solution to the differential equation. What column are they talking about in Danica's chart? Amount, rate, or rate of the rate? Jenna?
Amount.
That is the amount. How many knew? 2. Good. Where does this belong? Which column? Hands up. That should have been 3 pebbles. Sorry, 3 for that one. Which column is that, Brock?
Is that still the amount?
Still the amount. And you can translate that into like an XY table. If you knew that, give yourself 3 more. Hands up if you know what the XY table would look like.
Oh,
What would it look like, Kaylee?
2 and 3.
So 3 more if you knew that. The pebbles are flowing nicely again.
Yeah, this is how it's good.
Right. Pebbles waterfall. Okay. Pretty good.
When it says the particular solution to the differentiable equation,
I don't know.
I didn't know what that meant. Will you
Just need to memorize that means the amount equation.
amount equation?
That's
Okay.
all that means.
So
Means
same
that's
like
just another way of
solution
saying the
the
same
curve.
thing. Is that okay?
Yeah.
Yeah, say it again.
So
Say what you just said
solution
This
of
one
the
got
curve.
So hey, I'm going to give you several words. Listen. I summarized this once. Let me see if I got my notes on how I summarized it. So here's a lot of different ways to say it. Let's see. When they give you a differential equation, that one you know belongs in the rate column. Are you comfortable with that?
Yes.
So that's the word they assign to it. They call it a differential equation. So they say differential equation like this. That belongs in the rate column.
Okay.
Comfortable
but
there?
This one it says differential equation.
I'm getting there, but hold on a
Okay,
second.
okay.
So you okay with that?
Okay, yeah, I see.
So they say differential equation, that goes in the amount, that goes in the rate column. When they say solution of the differential equation, that's the equation that belongs in the amount column. Did you hear the difference?
Nope.
So the first one I said was the differential equation. So this is the differential equation right there. That's the differential equation
Okay.
in this example I have on the board. The solution of that equation is a different equation. And that different equation is the amount equation.
Okay.
It's just language. Like you just have to memorize that. Keep talking though. Don't stop. Good so far? That's it.
So the solution is where the original equation and the differential equation like intersect, like at that point, the 1, 2.
No. No, don't do that. That's not right.
Okay.
So we have one equation, which is the differential equation. Kaylee, where does the differential equation belong in our organizational chart?
In the amount or the rate column.
Correct. The differential equation itself, which is right here, that equation belongs in the rate column.
Yeah.
This new equation that we don't have, but they're talking about it in item C, that new equation belongs in the amount column.
Okay.
And they call it things. They call it the particular solution to the differential equation. Sometimes they call it the solution curve. Sometimes they call it the, here's some other, sorry Xander, here's some other examples.
Now that you was going to ask you is if they're gonna call it the particular solution, so that you already answered for me.
Yep, so right here, they're referring to the amount formula as the particular solution of the differential equation.
Okay.
That's the idea.
So it's not like a solution, it's just wording of.
It's just wording.
Okay.
There's a reason why it is, well, there's a reason why it's called the solution. Here's a quick reason. Like all of you answered this question. What is the solution? 3 pebbles for this. What is the solution of the equation? This is not meant to be tricky. What is the solution of that equation? Hands up. What is the solution of that equation, Paige?
2.
Better to say x equal to. How many knew? 3 pebbles. That's the solution of that equation. The reason it is the solution is because it is the x value which makes the equation a true statement.
Okay.
So when you have a differential equation like this, there is an infinite number of other equations that if you were to take their derivative and rearrange, you would get this. So they make the equation true. That's why they're called the solution. Questions? Can't tell if I'm helping, Lissy.
I don't know.
You're like,
Like,
I
I don't
can't
know
tell
either,
either.
actually.
Yeah, just say something seems to be bothering you. That's why I'm trying to help more.
Oh, no, I just,
Oh, so you're okay.
yeah.
So
yeah,
far, so good.
Yeah.
Okay, just making sure. I look for body language and expressions, and I don't know.
Yeah, no, you're good. I didn't.
He looks for the confusion on the face.
I do, and then I'm like, okay, wait a minute, that didn't work. Let's try something else.
So in C, is the differential equation y equals f of x? Or-
No, the differential equation is right here.
Oh, okay, okay.
No, you're doing great. The differential
Oh,
equation,
we're
what they
still
gave
on
us.
that.
Say again?
We're still over here.
Yeah, because it's still
Oh.
problem 4.
Oh, okay.
It's all on the same page,
Yeah,
right?
that actually took me forever to figure out. I was like, could not
Okay.
figure it out.
Hey,
Okay.
it's okay. Really, you're just getting used to the language. And that's why repeated practice is going to make you better, because you get more accustomed to the language.
Is this one the differential equation because it says it here? Like if they didn't say that was a differential equation, couldn't the equation in part B also be one? Like the differential.
You could think of this as you could think of part B as being a differential equation as well. Let's don't get too deep into that.
Okay.
I took 2 full semesters at BYU on differential equations.
That's a lot.
So it's not like a small
That's a
topic.
class.
It's
It's full differential
a, it's a
equation?
big class, it's a big topic. Yeah,
Oh.
two semesters.
Oh,
And that's probably just the start. You know? So I don't want to get too deep. Like
And then you
Okay.
stop. You know.
we don't go very far in this class. Like
Okay.
I'll show you how far we go, which is everybody okay so far?
So,
Yeah.
all they're saying is that y equals f of x is the y. Or like the first column in the Damascus chart.
Perfect.
Right?
That, and I just always call that our amount equation.
Amount equation.
Yep.
Okay, got it.
And Lissy, do we happen to know the actual amount equation in this case?
Yes.
We do?
Yeah, because it's the antiderivative of this.
Oh, that's fair. But we don't know that.
Oh,
Like what I said.
no, we don't.
I didn't ask that. Look, I didn't ask that very well.
Okay.
Your answer was actually very correct. I just did not ask a very good question. We know the differential equation.
Uh-huh.
I can't write down the specific formula for the amount. You know, I don't know what to write because we
Okay.
haven't found
Because
one.
you have no.
Is that okay?
Got it.
Hey, I'll give
20 pebbles.
Yes.
19
10.
pebbles.
I'll give 10.
10
I'll give 10.
How about
You
we-
can answer this question.
Okay.
You can answer this question. You can talk to each other even,
Okay.
and I'll still give you 10. So you can help each other.
Okay.
So I want everybody to get to 10. Okay, here's the question. Hey, here's the question. It's a series of questions. So we're going to knock over some dominoes here.
Okay.
So the first domino is something I just asked. I just want you to say it again because it'll help with the video. We have an equation for the rate column, yes or no?
Yes.
So can we find the rate? There's no story here, it's just x and y, which means rate means slope. So can we find the slope of the amount? Like there's some graph, we don't have it, but there's some graph for x and y, and if we had that graph, could we find the slope at every point on that graph?
Yes.
How would we do it?
Yeah.
Plugging it into the differential equation.
Yeah.
Raise your hand if you're confident in that.
Yes.
Okay, so we're on track for the 10, it might be even more, we're good?
How
about we raise it
to
I'm liking it. I'm liking
You
that.
can tell my body language, right? Yeah. No, you can tell. People, I always think it's interesting, you'll talk, no offense, but I think it's interesting when you talk to teachers sometimes, they'll ask me like, how do you, because I used to teach 7 calculus, and I come early and I stay late, and I come on 7. How do you do that? Like, you just do the same thing over and over. No, it's not the same thing, because it's different people. And I'm serious, all I care is that you get it. So as soon as you start to get it, I can't stop getting excited. So, good. Okay. We good so far?
Yeah.
Okay. Raise your hand if you can answer this. Do we have a way right now to plot all of the XY pairs that make up our amount formula? Hands up. Do we have a way currently that we can plot all of the XY pairs? Michael?
No.
How many say no? So we're good, right? And we don't have a way yet.
But we do know 1 point.
We do know 1 point.
We're
And
pretty
that
much
one
halfway
point
there.
feels really useless right now.
I would agree. I would agree. I would agree. I'm not sure why that's not helpful, but we got one.
Okay.
$1 billion.
Okay, we got one. Okay, now here we go. Here's the money shot. So I'm smiling too much. Terrible poker player.
I am too.
Does anybody know what box on the golden notes would give us a process at least that would guide us to a formula, which would then allow us to find all of these XY pairs? Not one of them, all of them. Raise your hand if you know the box on the golden notes that really would allow us to follow a process, and that process would create a formula, and that would be the amount formula. Talk to each other. This is the money
Okay,
shot.
oh, no, that's fine one.
Sassy.
This is the money points.
Oh, we all agree. It's in
So-
sassy.
We have the differential equation. I want to know, is there some box on the golden notes that says, hey, if you follow this process, you're going to get a formula.
Okay.
And that formula will find every XY pair.
Okay.
All of them. For the amount formula. Yeah.
Okay.
I feel like we should dock them 1 pebble and then get a hint.
We need a bit more time.
I actually think you're going to be fine.
I think you can. Wait.
Okay, my point is, I didn't say can. My
Wait,
point is there a box that says a way to do it?
Stop, halt.
I got it.
Is there a box that says there's a way to do it?
Yes,
Just give us a
there
second.
is.
That's all I want.
Yes.
You're good, you're good.
Giving
Keep
you a
going.
break.
Oh,
Find
yeah.
them out or formula. Use the fundamental theorem.
I knew it was sassy,
It's
right?
like the best video ever.
Was it sassy?
Yeah.
Okay, so
Okay.
Yeah, that's what we were wrong.
raise your hand if you're comfortable that the purpose of the sassy method is to do what I just described.
Yeah.
So the sassy method is to go from a rate,
From a differential equation
a rate equation to an amount.
to but it's specific. Hey, look at the golden notes. Look,
Okay.
hey. Notice how the box on the right, you all found the box on the right, yeah?
Yeah.
Notice how the box says, if my rate equation contains the output variable, I must use sassy,
The output
Which is your Y.
which is the y,
So there's a Y.
okay? Yes,
We got one.
that's the box, right? It is the box. That is the way, man. Mandalorian all the way. This is the way. Okay? I got a new slogan up there. Yeah, this is the
I know,
way.
I just said
I
that.
don't
This is the
understand.
way, so-
Natalie, help.
Okay,
I don't know how to do these.
are we good? Okay, mark, don't grab it, it's too loud. Mark down 15, that was outstanding. Yeah! Woo! Nicely done.
Pebbles.
Nicely done. Super good, super good. Is everybody okay? Okay, I'm not saying we need that for this problem, but from your questions, it really felt like that would help to just get that big picture understanding. Once you have the big picture understanding of what is meant by a differential equation, I promise, you just open the door to like 8 points every test. Every test. 7 or 8 points, guaranteed. But you just have to keep that relationship in mind, like amount versus rate. And what do the words mean? And then you're good. So here, let's keep going. Does F, hands up. More pebbles. What's F talking about? It's always just keeping track of those 3 columns. That's why Danica's chart, you know?
Yeah.
That's it. What's that talking about?
An amount.
This is the amount formula still. How many new?
Oh.
3 more? Yes. So does the amount formula have a relative min, relative max, or neither at x equal 2?
Oh, that's so much easier now.
What?
Yeah.
Wow. I don't get it. I'm not seeing it.
Let's keep talking.
Wait.
Hey, let's keep talking.
You already know.
Here we go.
They gave it to you.
So I got to do some work now.
Plug in.
Got to do some work. So that's my, hey, help me. You got the problem in front of you. This is the differential equation, yes?
Yes.
Okay, so I'm going to do a sign chart.
Oh, I did a sign chart. Oh my gosh.
Actually, this is a harder one still. It is harder.
Would you skip this one or would you technically?
and x equal 2.
So, okay, I have a question.
Yeah, this one's harder. I would skip it.
So my thought
But the
is,
discussion we had was good.
Yeah, probably.
But I would still skip this one.
okay, so here's my thought.
Yeah, go.
So f is gonna have a relative min or max when f prime goes from positive negative or negative positive. So if it's asking at x equals 2, then do you just find f prime at x equals 2 and see if it's
Maybe it works better. Maybe I'm
Like
giving up too
zero?
easily.
That's my thought
Let's keep
too.
going for a minute.
That's
Maybe
what
I'm
I
giving
did
up
too,
too
but
easily.
I also did a sign chart, so.
I think I'm actually giving up too easily. My bad. I apologize. I went to sign chart.
Doesn't seem bad.
Pause for it. Pause. Think. Okay, I did what I tell you not to do. Like I say, don't solve a problem based on a problem.
Concepts.
Yeah, think of concepts. Lissy's in a good place. Like we're gonna go find.
Let's see.
We're gonna go find dy dx. This one actually turned out to be easy. I messed up.
Quick question.
We all do. Hold on one second.
No, hang on.
What's the point we're trying to find?
2.
Two.
But we know the y, yeah?
Yeah.
Yeah.
So, all of you, raise your hand and tell me what do I write now? Hands up. Come on. What should I be writing now? Like read the math. Tell me what I write. Pebbles. That's what do I write?
Would you do 2 parentheses 2 minus 3,
And that's gonna equal what, Beth?
1?
So we're done.
No way.
I think
It?
Wait, what now?
You do need to just.
Oh wait a minute. No wait.
Yeah.
Wait,
I
doesn't
still messed up.
Well,
Still
wait,
messed up.
that's the
Okay.
slope, right?
Yes.
The
What I
point
know
of
now
x
is I know
equals
that at
Oh.
x equal. So I know at 2 comma 3. This is probably
Hard.
bugging me.
Me too.
2 comma 3 f of x
two has a slope.
is increasing.
Oh, gosh.
We're okay now. Is increasing because
The signs are the same.
Which means that there
Sign
can't be
it there.
because dy dx
Oh, it's
I'm pretty sure
positive.
that we
Oh,
were.
wait, so-
at 2 comma 3 is positive. So that's not a relative min or a relative max. It's a neither.
That's the answer.
That's it.
You
would Wait.
still.
I think we are geniuses.
Let's talk until we get it.
Explain it why. You know, it's just like, we just have to
Take
count
over.
1 point, so it's positive. I understand
Yeah.
it's increasing, but how do you know that it's not like
I'll take, or here we can just
changing,
deny that.
that relative?
I know exactly.
I'll take
Good job.
2.
I know exactly your question.
Don't you have
Hey,
to find zeros so you can?
I know exactly your question. Look up here. Look up here. You are thinking in a really good way. Because you're actually, it makes me feel good because I was thinking the same way. Hey, I'm all right. Brock not like I brought. At least I'm as smart as Brock. So. Okay. Look, hey,
It's just, she left, so we're just passing.
and they're very clever at Brock. I know that's how they designed this. Like they just knew they would catch a whole bunch of us and like, I gotta figure out if I'm increasing or decreasing. Not really, because they already told us where, like if it had been 0, we'd be in trouble. Like if we had done all this and this was 0, then I would know quite what to do next.
And then you get on.
Okay? But because it's
At that
1,
point, you move on.
because it's 1, I know the graph of f is increasing at that point. If a graph is going up, there's no way for the graph to have a relative min there, a relative max there. A relative max always occurs at these kinds of spots.
Couldn't it technically be a relative min or max if that was the end point, like the end of the time period?
Oh.
You can't have a relative max in
That would
an
be
endpoint.
absolute max.
Yeah, you
Because
have to have
the
absolute max.
You could be an absolute max, but you can't have a relative max at an endpoint because the graph's got to change back.
Okay.
It's got to change back. I don't know if that helped you at all, though. That was not a very good explanation.
That confused me.
Let's no one talk so I can try again. Hey, no one talk, no one talk. So, okay, let's go step by step. Are you okay with the computation?
Yes.
Good. Are you okay that that's basically f prime?
Yes.
And so we know that f prime is positive. So are you comfortable that that means f is increasing? Good. So if f is increasing, f's going up. That can't be relative max. Relative max always occurs at a transition between f going up and f going
It
back
would have to be
down.
a 0.
Not just f going up.
Yeah.
That's why I said if this had turned out to be 0 right here,
Then we would.
then I'd be like, okay, now what do I do? Like, I can't tell what's going on. But because it was positive, I'm
So if we
okay.
undefined if there's like
So
that.
like, how do we know f prime
Yeah.
never goes negative?
Oh, it could, but we're only looking at one
Which
spot.
totally could still be an R max.
We're not looking
Well, I
for,
needed to hear.
you're okay, do you see the difference?
Yes, yes.
Yeah, yeah, no, it's good work.
It's not,
Hey,
it's not interval, it's just one, okay.
just one spot,
Yeah.
but that's why they messed us up. Fair?
Yeah.
Yeah, they got us, they got me messed up.
Okay, so
What did you hear?
hypothetically, you have an undefined slope. on a differential equation, that could still be an R min or an R max on F. How are we supposed to know if it?
We would need more information.
Okay.
Yeah, that would be this situation where we'd go to find the derivative, like, oh, it's undefined. So that means F had a corner or something, and we don't know what to do, so we would,
That's where it starts.
different problems.
That's when you move on.
Yeah, if it's zero, do you
I give
just
up.
move on and get love? Is that what you done?
For this one, I would have moved
Scream
on.
out in the middle of the meeting.
I'm done.
Hey, remember my rule,
You knew that.
remember my rule,
I'm like,
hey. Listen, remember my rule. My rule was if I'm working methodically and I can feel like I'm still progressing, I keep going. The instant I feel stuck, next problem.
Okay.
I don't sit and ponder, just next problem. So,
Whoa.
it was only 2 points. You got 1 point for doing the
Which I feel like
computation.
it's lame. It should have been more than that.
Yeah, that should be like 8
The good news is this, though, I promise. A lot of, hey, listen, Jenna makes a good comment. A lot of times, the problems that are the most annoying, the most like, how in the world did they come up with that? They don't get very much for it.
They did it.
They're just traps.
So
Please.
on mine, I put, like, is this a good enough justification to
Go ahead.
the point? At x equal 2 on F, there is neither a relative min or max because the slope of that point is 1.
That would be
Do I have to
perfect.
keep
That's perfect. That would be 2 points. That's well done.
Wait, they did like, I think they did the SAS